here to present a research idea, a biomaterial science research idea. So most of the talk will be kind of based on material science, and my apologies in advance, the AI part will be very, very basic because I know nothing about AI, so please bear with me. I'm here to get your input today, and possibly a collaboration as well. So my title that's printed is actually quite long. I've decided to shorten it. So, so it's about using AI as a predictive tool to screen next generation bone joint implant coatings. So for context, there are many different types of bone joint implants. So hip, knee, spine implant, the global market is about 20 billion US dollars. The demand will increase by 39% come 2050. The NHS in the UK alone spends £1 billion, £1 billion a year just on hip and knee implant surgery. So that's a lot. The thing is, bone joint implant, the failure does occur. The rate is quite low, it's approximately 10%, but there'll be more and more people getting implants, so there'll be more and more people experiencing failure. Revision surgery that replaces failed implants is expensive, it's invasive, it's painful, and when it comes to revision surgeries, you can see the NHS treats 15,000 cases a year, and it can be up to £100,000 per case, depending on complexity. Now, in terms of a potential solution, if we can eliminate the failure of implants, we can eliminate revision surgery. And a solution is to increase the bioactive ability of the implant's coating. So it's not just the implant in and of itself, but there is a bioactive coating on these implants so that the body's natural bone cells can attach and grow. So creation of improved implant coatings in the early stage preclinical lab is resource intensive, it's complex. The conventional research data is generally multimodal. So there will be microstructural data obtained, there will be images as well as biological statistical data. But cross-lab data is not consolidated, even though there's a lot of data out there. So AI work is at its relative infancy. It's not at its infancy, it's at its relative infancy, and obviously the potential of reducing time and expenses. So this is where the ask is to either get input, free input would be great, and a collaborator to maybe co-design a 4 to 6 week, maybe a pilot, a viability test if you like, to look at how we could predict the probability of human cell growth on new implant coating candidates using pre-obtained wet lab data that's publicly available. So PyTorch, possibly PyKale would be a good candidate. And then the first stage is to turn this available results using a structured, into a structured data set so we can map features. And then the second stage is to implement a predictor. So it learns from this data, and the data would be, this data set would be quite small. And then over time, can that be generalized to new coating candidates? I mean, the other issue as well is that when you find a type of new material and you combine it with another one, that can create other complications as well. So can AI help? So in closing, the goal is to reduce the resources needed for developing bone joint implant coatings by using AI as a pre-validation screening tool. And perhaps we can leverage existing multimodal wet lab data to train a model to predict the probability of cell growth on new untested coating candidates. So that's it from me. If you'd like to email me, there it is, and that's my LinkedIn as well. So thank you very much.
Thank you, Jane.